What is correlation? Correlation determines if a relationship exists between two or more variables, and if so, to what degree the relationship occurs. There are many types of correlation. There is a positive correlation, negative correlation, strong correlation, and weak correlation. As you can see in the graph, the examples we have here are a strong positive correlation, a positive correlation, negative correlation, and no correlation. Correlation coefficient R. 1 is a perfect positive correlation. 0 is no correlation, the values don't seem linked at all, and -1 is a perfect negative correlation.
Now it's time to talk about the 3 different types of correlations. The first one is Pearson's product moment correlation. This one works on an interval or ratio scale, which means that the points are equidistant from each other, kind of like temperature, or they can't have a number less than 0, like weight. Another thing to note about it is that it's linear. The points form in a kind of straight line, and it's obvious that there's a correlation here. The points are normally distributed. Pearson's product moment correlation doesn't consider outliers if a point was out here or way over here. The last thing to note about it is that it's homoscedastic, which means the variances are very close to each other. If it were heteroscedastic, there would be variances from between here to between here, and it wouldn't form a very clearly defined shape. The second is point by serial correlation, which also runs on a ratio or interval scale, which means that they're equidistant from each other and they can't have a number less than 0. The second thing to note about this one is it deals with continuous variables and a dichotomous variable, which is binary. So they only have 2 options, kind of like sex. The third thing is that it can be solved with a t-test. Spearman's rank assumes ordinal data and frequency. Ordinal data is ranking order, and there are no assumptions about distribution, because if you were measuring people who were running in a race, you would count when they passed the finish line. You don't count, it's not a constant number. They're passing at different times. So this order doesn't take into account the strangeness of outlier. So if you have a really fast person who runs a 5-minute mile and a really slow person who runs a 30-minute mile, this would still take into account the order and not really the strangeness of somebody passing in a 30-minute mile. So the last thing to remember is that rank is the most important thing for Spearman.
Hey guys, so we're going to talk about the inferential statistics. And to start off, we need to know the results, that if the results are significant or not. Inferential statistical test explains if results were to occur frequently or rarely by chance. The smaller the values occur frequently, while larger values occur rarely by chance. If results occur often by chance, it is not significant and conclude independent variable did not affect the dependent variable. We then accept the null hypothesis, which is a hypothesis that says that all differences between groups are due to chance. If results rarely happen by chance, then it is significant. If event rarely happens by chance, then it must be 5 or fewer out of 100 replications of the experiment, which is the 0.05 level of significance, quote unquote. We use the t-test, which is an inferential statistical test, is used to evaluate the difference between 2 means. After finding the t-value, you must find the degrees of freedom using the equation degrees of freedom equals na minus 1 parentheses plus nb minus 1 parentheses. Which includes the degrees of freedom is the ability of a number in a specified set to assume any value.
Now, we're looking at one-tail versus two-tail t-tests. One-tail t-tests are based on a directional hypothesis, whereas two-tail t-tests are not. That means for the one-tail t-test, you're putting all your eggs in one basket because it's a one-side only result. For the two-tail t-test, You have more wiggle room because the result can fall on both ends of the distribution. However, your p-value has to be less than 2.5% of the distribution on either end. Whereas with the one-tailed t-test, your p-value has to only be less than 5% of the entire distribution, but only on that end, not both. So if you're nearly certain what direction the result is going to take, you go with the one-tailed t-test. And if you just know there's a difference but not in what direction, go with the two-tailed t-test. Next, we're looking at the errors we can make after conducting the experiment. So you have a 2x2 matrix in which you compare the actions you took to what's actually going on in reality. So, if you reject the null hypothesis, but in reality it's actually true, you just committed a type 1 alpha error. Let's move on to the next quadrant. If you fail to reject the null and the null is true, that's correct. It's the same vice versa. If you reject the null and it's false, that's correct. However, if you do not reject the null, but it happens to be false in the real world, you just committed a type 2 beta error. Finally, we're going to look at the effect size. T-tests tell you if there's a difference, but not how big that difference really is, so we have to account for it somehow. You can calculate the effect size with a really complicated formula, or you can just use the variance, which is the standard deviation squared. If our effect size falls between 0.2 and 0.5, it's small. If it falls between 0.5 and 0.8, it's medium. If it falls between 0.8 and 1, it's large. So the result is significant. Whatever the percentage is, that's how much the correlation accounts for the variance.